of the river and alluvial fan of the Jezero Crater. I'm sorry, it's a weird name. So right now we are trying to model the sways and turns of a river and go into our alluvial fan right here at this kind of wall shape here. We have modeled after the edge of the crater, so we will have the crater here. This would be the edge where the lip has been created from impact and also from the breaking down of the edges from erosion with the lake. And here we have our river with varying depths and heights and curves. It can be modeled after an older stream, as it's got a lot of curves, and a newer stream may be more direct and less wide, with less deposition at its corners and curves. Oh, also to note that this is going by 1 liter at a time, and this is our first liter of water going through this river.
What are some observations you expect to find?
I'm hoping that with the sediment at the bottom of the bed of this river, that we start to get at least some sort of delta or alluvial fan shape at the end here, and we already are starting to have the erosion of this bank at the edge and these walls. And we are starting to get the erosion of the bed right here and seeing the exposing of rocks. So yeah, I expect to see some sort of delta shape in this region right here. And we are starting to get one, but we still have quite a bit of water to go through and quite a bit of silt to pick up from the bottom of this. So yeah, I'm a bit to go till we get that formation. So here, after going through a liter and nearly half, we've started to get a development of an alluvial fan going. We're seeing the height of it right here, where it's being pushed down and sediment's creating kind of a pyramid shape and pushing it outwards. And we're getting that buildup going around because, as you can see, you have the bank with little to no shore on it, and then we're starting to get this outwards cone shape, and I expect it to grow maybe by half inch or so by the end of this process. Our third liter and on to our fourth, we are definitely starting to get an absolute formation of a alluvial fan. It's spreading out, and as this is quite a flat stream table, we are seeing that we have this deposition here, and there's little areas similar to, I don't know, an octopus's tentacles, where it's going out and we're having little spots where there maybe have a fan. Well, yeah, we're definitely seeing the formation of that. And with the material of this stream table, we tried to, although very rocky, as we are in Montana, the silt that we're trying to have, I believe this does come from a riverbed. And so it's very fine silt that's being put through here. And similar to the very fine silt that we would find in volcanic ash and other dirt and soil that we would see on Mars' surface, and that we would see in that alluvial fan and that river that we were trying to model here, at least supposedly. We won't see till the mission.
Can you draw any conclusions or make any observations from what we see here on this stream table?
Well, I think the obvious conclusion from what we see here, and although this is very small scale, I would say that without a doubt that the thing we are observing on Mars in the crater is an alluvial fan. You could just see with that curves and that angle that leads into it that it could be nothing but water, and how when we observe the alluvial fan that it is very sprawled out and angled at the very edges with a sort of bank that suggests that maybe there had been a delta, and then as the water lowered and lowered and lowered, eroded at the edge of the delta. And I think we can see very similar things here, as we have this kind of edge here as the water kind of goes back. It may not be the same process exactly, but we have the water come back, and it does flow a bit forward, and we have similar to maybe erosion, and we have a alluvial fan and this kind of edge, very definite edge, instead of being completely smooth process and transition in.